Good morning everyone. Today we look into the second module, that is differential equations of higher order. Higher order differential equation with constant coefficient is given by the equation d to the power n into y divided by dx to the power n plus a1 into d to the power n minus 1 into y divided by d into x to the power n minus 1 plus so on plus an minus 1 dy by dx plus an into y, which is equal to pi of x. Here you are observing a1 so on up to a1 to up to a nth term. These are all called as constant of differential equation of nth order with constant coefficients, and this equation can also be written as d to the power n plus a1 d to the power n minus 1 plus so on up to plus an minus 1 of d plus an of y, which is equal to pi of x or p of x. Here the capital D, whatever we are writing, that is nothing but d divided by dx. This d divided by dx is equal to capital D, and whatever the power, that power, and this y we have taken common here. Okay, therefore capital D is equal to d divided by dx. Here we have to note that if p of x is equal to 0, when the RHS is equal to 0, then that differential equation is called as homogeneous differential equation. If RHS is not equal to 0, then it is called as non-homogeneous differential equation. Now we look into the solutions of homogeneous and non-homogeneous differential equation. First, homogeneous differential equation. Let us consider the differential equation of the form d square y by dx square plus a1 dy by dx plus a2y, which is equal to 0. Already I say that when the RHS is equal to 0, then we say that the homogeneous differential equation. I am considering a general equation, and this can be written as, where d by dx can be written as d. Therefore d square plus a1 into d plus a2 of y, which is equal to 0. Whatever we are representing that given equation in terms of capital D, that will call it as auxiliary equation. Auxiliary equation, in short, we will write it as A dot E. Then for this auxiliary equation, this auxiliary equation will find the roots by the factorization method or by the applying the Sridhar's formula or by synthetic division. Then we are going to arrive two roots. In general, I will say it as y1 and y2. Therefore, if f of d of y, which is equal to 0, that is f of d y1 is equal to 0, and f of d of y2, which is equal to 0. For the auxiliary equation, I am going to write the complementary function with those roots whatever I get, that is called as c1 y1 plus c2 y2. c1 y1 plus c2 y2. c1 and c2 are the constants here. When c1 y1 plus c2 y2 is a solution of differential equation, this solution can be written as yc is nothing but complementary function of that function, that is, which is equal to c1 y1 plus c2 y2, which is called as complementary function and denoted by yc. While solving the examples, you will exactly know what is complementary function and how to find the roots. Now we'll move on to the solution of non-homogeneous differential equation. That is nothing but the RHS must not be equal to 0. Therefore, if f of d of y, which is equal to f of x, then here if yp is a particular integral, then f of d into yp, which is equal to f of x. That is f of d, which is equal to yc plus yp. Yc is nothing but complementary function, yp is nothing but particular integral. This both will give you the complete solution, that is y is equal to f of x. Now the question arises, how to find the complementary function. I'll consider second order homogeneous equation, that is d square plus a1d plus a2 of y, which is equal to 0. This can be written as m square, d capital D is replaced by small m square plus a1m plus a2 of y, which is equal to 0. Okay, and where a, this is your auxiliary equation, and this is called as quadratic equation which has two roots. Note, here we have to note that depending on the roots we are going to write the complementary function. Please observe carefully. If the roots are real and distinct, that is if the roots are real and distinct, that is m1 and m2, then the complementary function yc will be written as c1 into e to the power mx m1x plus c2 into the e to the power m2x. If the roots are real and equal, that is m1 is equal to m2, then complementary function will be written as c1 plus c2x into e to the power mx. When the roots are imaginary, then we are going to write the complementary function yc as e to the power ax plus e to the power ax of c1 cos bx plus c2 sin bx, a plus or minus ib. When the roots are in the form of a plus or minus ib, a will be the exponential, then b will be writing inside the bracket. For example, here if the roots are 4 and 4, here the roots are real and equal, the second note, therefore yc I can write it as c1 plus c2x into e to the power 4x. In place of m we have 4. Next, plus or minus 2i. The roots are imaginary here. So the imaginary part only is there. Therefore, this real part is not there. Therefore, I will write it as e to the power 0x into c1 cos 2x plus c2 sin 2x. Next, if the cubic equation is there, then I'll get three roots. Therefore, when the roots are 0 comma minus 2 comma minus 2, then here these two roots are equal and this is different. Therefore, the complementary function will be c1 into e to the power 0x plus c2 plus c3 of x into e to the power minus 2x. When the roots are imaginary, this type, like similarly here the roots are real and distinct, therefore the complementary function will be c1 into e to the power 3x plus c2 into e to the power 2x plus c3 into e to the power 6x. Now we'll solve the example. The first example, y double dash plus 5y dash plus 6y, which is equal to 0. This I will write it as d square, double dash means it's a second degree equation, therefore d square plus 5d plus 6y, which is equal to 0. Then the auxiliary equation, the d is replaced by m, small m, therefore m square plus 5m plus 6 of y, which is equal to 0. That is m square plus 5m plus 6, which is equal to 0. Please factorize it by normal factorization, that is m square plus 2m plus this is 3m plus 6, which is equal to 0. Take m common, m plus 2, and here 3 m plus 2. Then I'll get m is equal to minus 2 and m is equal to minus 3. Here the roots are real and distinct, therefore the complementary solution will be yc is equal to c1 e to the power minus 3x plus c2 e to the power minus 2x. Now we'll go further, that is second example, d square y by dx square minus 6 dy by dx plus 9y, which is equal to 0, which can be written as d square minus 6d plus 9y, which is equal to 0. Auxiliary equation, m square, then here it is plus 6m plus 9 of y, which is equal to 0. 3 3s are 9 and 3 plus 3 is nothing but 6. Here it is plus m square plus 3m plus 9, which is equal to 0. Please note that here it is a plus. Then m into m plus 3 of m plus 3, which is equal to 0. Then m is equal to minus 3 and minus 3 I'll get. Then the roots are real and equal, therefore the complementary solution will be c1 plus c2x into e to the power minus 3x. Now the third example, y double dash minus 4y dash plus 13y, which is equal to 0. This can be written as d square minus 4d plus 13y, which is equal to 0. That auxiliary equation, d is replaced by m square minus 4m plus 13 of y which is equal to 0. This cannot be factorized, therefore I am applying Sridhar's formula, that is minus b plus or minus root of b square minus 4ac divided by 2a. Here a is equal to 1, b is equal to minus 4 and c is equal to 13. Apply in this formula and you are going to, after simplification, you are going to get the answer as 4 plus or minus 6i divided by 2. Here I'll take 2 out, then when I take 2 out, 2 into 2 plus or minus 3i divided by 2. 2 and 2 will get cancelled. Then the roots is complex, therefore e to the power 2x, and this plus or minus 3i, that is c1 cos 3x plus c2 sin 3x. Next, fourth example. Please observe the equation is cubic, that is d cube minus 6d square plus 11d minus 6 of y which is equal to 0. When the equation is cubic, then you will get that 3 roots. Now, it cannot be solved by normal factorization method or by the Sridhar's formula. Therefore, by the inspection, we are following here synthetic division method. First, we are going to write A, that is auxiliary equation, that is m cube minus 6m square plus 11m minus 6 of y which is equal to 0. Please substitute m or x is equal to 1 in that equation. Means in place of m I have to substitute 1. When I substitute 1, it must be equal to 0. If it is not equal to 0, then go for the next number, that is 2. If 2 is also not equal to 0, then 3, that is here here. If x is equal to 1, I substitute that 1 cube is nothing but 1. 1 minus 6, 1 square, that is 1 minus 6 plus 11 into 1 is 1 minus 6. Here simplifying, here 1 minus 6 plus 11 minus 6 which is equal to 0. Therefore, by inspection, I can say that x is equal to 1, and please write the coefficient of this, that is m cube coefficient is 1, m square coefficient is minus 6 and m coefficient is 11, and that last term minus 6. Whatever the number is here, x is equal to 1, that is by the inspection I got, and whatever the number is here, that I have to write here down, that is 1 here, therefore 1 also here. 1 into 1 is 1, 1 into 1 is 1, therefore minus 6 plus 1 which is equal to minus 5. Next, minus 5 into 1 is minus 5, therefore 11 minus 5 is equal to 6. 6 into 1 is 6 and this will be 0. When you apply the synthetic division method, the last term will going to be 0. So here this is unit, tens and 100, that is m square minus 5m plus 6 which is equal to 0. Now I can factorize it, and by factorization I will get the roots as y is equal to 2, sorry, m is equal to 2 and m is equal to 3. Here one root is there by the inspection, and here 2 roots. Totally for cubic equation 3 roots. So here 1, 2, 3. The roots are real and distinct. Therefore, the complementary function will be written as yc is equal to c1 e to the power x plus c2 e to the power 2x plus c3 into e to the power 3x. In the next class, we'll look at some more examples.